Hello to everyone, welcome to my channel. Today we have some electrical engineering task here and we need to find the equivalent resistance. We have 7 resistors here and we will find the equivalent resistance. So now let's consider first this these two resistors. So we have here we have three nodes, 1, 2, 3 nodes, and a wire, a connectors between two nodes. So the wire have the resistance of the wire is 0. It's ideal conductor. So and let's look at the connections of this of the resistors in this circuit. How they are connected. These nodes and this node are the same because they are on the same wire, and if the wire has the 0 resistance, it means that all the points have the same potentials, and that's why this node and this node can be considered as the same one. It means that these two resistors are connected with at least one point with the same node, and with there another end of these resistors is also connected to the other point. It means we can redraw this circuit, this part of the circuit, as this. This is, for example, let's denote it as a C here, C, and so this is also a C, and this is also a C. So how these two resistors are connected? This is A, because here we have A, and here we have here we have C. What we get parallel connection, not series, but parallel connection of these two resistors. These two resistors connected parallel with each other. Now let's look at another resistors, this one, and this one. These three resistors. How they are connected. How these resistors and these resistors, they also connected to the same point, to the C. And this also connected with one wire, with one end, it's connected with C. So we have 3 resistors which are connected from with the same node with one end. And what about this one here? This if this is C, let's denote this like B. and B also. So as I told, here, everywhere the potential is the same. So any point in this diagonal in this wire can be considered as the same, and here as well the same. And here what we see, one end of these three resistors is connected to C, and another point here B, and here this one B, and this one is also B. So they connected with one point to B and with one point to C. You see, but there are not two but three. I hope you understand the point. The point of a parallel connection, parallel circuit, is that they connected to this, with one point to the same node. They have 2 points with 1 point. All of the resistors in the circuit, if they connected to the same point, all of them, it means that this connection is parallel. The same for other and other ends of these resistors must be connected to another same node. So one end connected to one point, another end to another point. This means that they are parallel. So here these three resistors, they connected to one with one end they connected to C, with other end they connected to B. Here the two ones, this one and this one, and here the third one. Now let's draw it. Redraw. This is the second one. And this is the third one. And this is, if this is C, this is B. B. So we have two parallel here and three parallel here. And these two parallel and three parallel connected with each other. How? With series. What is series connection? Series connection if the resistors connected with each other with one point with each other, and one point with another resistor or battery, like this. For example, if they connect it like this, it means that they connected one point with one point, only with one point with each other. One point with other, one point with one point with other. But parallel is when they connected with one point, all of the resistors connected with one point with the same node. So here it means that what is the formula for parallel connection, for parallel circuit, and for consecutive circuit or series circuit? For parallel circuit, the formula is like this: 1 over R is equal to 1 over R1 plus 1 over R2 plus, and so on, 1 over plus 1 over Rn. 1 over Rn. This is for parallel. And for series circuit, the formula is like this. Yeah. Equivalent, R equivalent, and here R equivalent is equal to the sum of R from 1 to n. So let's find first. By the way, now what about these two connectors? These two resistors, they have here a node, but this node is not connected to the supply. Supply is here and here. Here is, for example, plus, here is minus, or vice versa. It does not matter the order. This point is not connected to or either B or A, because the current begins from here. It goes like this. It is here, and then like here to B, or from here like this to B. But these two resistors are outside, because this point E is not connected to here. It's not connected to B or to A. This connected to B, yes, to B, to this wire, but it does not connect. It is not connected to supply. That's why the current will go from will be only here, but these two resistors will be outside of this circuit. So now let's and these two circuits are connected series, as a series. Now let's calculate. Here we have two resistors. 1 over R is equal to 1 over R1 plus 1 over R2, and it is equal to R1 plus M times R2. Here R1 plus R2, and we apply the rule of fraction. Here R is equal to what? To R is equal to this times this over this. Now, so R is equal to R1 times R2 divided over R1 plus R2. And the second circuit, 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. and this is equal to R1, R2, R3, R1 plus R, yeah, sorry, here will be R1 R2 R3 plus R1 R3 plus R1 R2. I hope everything is visible here. R1 R2. Yes. And we will apply the same rule. R is equal to plus R1 R3 plus R1 R2. So now imagine that they are the same. Here, what will we have here? If all these are equal, what we have here, r square we have here over 2r. It means that we have here r over 2. Here, if we have the only 3, we will have here r cubed, and here we'll have 3r square. Square and cube cancelled out, r over 3. And now we can calculate all of the equivalent resistance. This is series connection, so we will apply this rule, the second rule, for here and for here. R equivalent is equal to r over 2 plus r over 3. What is equal to? Here will be the 6. Here will be 3r. Here will be 2r. So the equivalent resistance will be 5r over 6. And that's it for today. I hope everything is clear. If not, you can ask the question in the comment section. I will answer them as soon as I can. Thank you very much for your attention. Have a nice day. See you in next video. Bye.